Wherever you are right now, I hope you're settled, perhaps lying down, or simply allowing your breath to rise and fall without rush. Tonight, we will drift together into the quiet, shimmering landscape of quantum energy, a place where the universe behaves like a whispered secret, revealing itself in soft pulses rather than grand announcements. So let's take this slowly, like watching dawn spill over a sleeping valley. Quantum energy, it sounds mysterious, almost mythical, like something drawn from a forgotten scientific poem. Yet, it is a real and foundational idea at the heart of modern physics. It tells us that energy, at its smallest scales, is not a smooth river, but a collection of tiny steps, discrete packets called quanta. Long before we could imagine computers, space telescopes, or particle colliders, this idea was quietly waiting in the mathematics of nature, patient and unchanging. As you breathe gently, imagine the universe as a vast ocean at night. On the surface, everything seems calm, continuous, predictable. But beneath, in the hidden depths, life moves in tiny flickers and pulses. Quantum energy lives in this deep layer where particles appear and disappear like bioluminescent creatures rising from the dark. Nothing behaves exactly as we expect. Nothing is ever fully still. Even emptiness, the vacuum of space, is alive with fluctuations, tiny waves of energy dancing in silence. This idea first entered science not through thunderous discovery, but through a quiet crisis, one that puzzled physicists more than a century ago. They were trying to understand something as ordinary as how objects glow when heated, the warm red of iron in a forge, or the soft orange of an old filament bulb. Classical physics predicted a glow that grew infinitely intense at shorter wavelengths, a contradiction so severe it earned the name the ultraviolet catastrophe. But nature refused to follow that prediction, and so a gentle shift began. In 1900, Max Planck, working late by lamplight, introduced a radical thought. Perhaps nature does not hand out energy continuously, but in tiny, indivisible packets. He didn't fully know why it worked. He only saw that it did. And that single idea would become the seed of quantum theory, growing into one of the most profound revolutions in human understanding. Quantum energy means that atoms vibrate in steps, not slopes. Electrons absorb and release energy in discrete amounts, like climbing or descending tiny ladders inside the atom. Even the light that reaches your eyes right now, as you read this, comes in quanta, called photons, each carrying a precise amount of energy determined by its frequency. This may feel abstract, but picture it this way. Imagine trying to climb a staircase in total darkness.
You expect each step to be the same height, the same distance apart. But in the quantum world, the staircase is strange. Some steps are tall, others vanish, and others seem to appear only when touched. Energy is not a smooth ramp. It is a delicate architecture of possibilities. Let's stay here for a moment, in this gentle ambiguity. Quantum energy is not chaotic. It is simply different from the world we see. If the everyday universe is a painting, quantum reality is the brushstroke beneath the paint, fine, hidden, fundamental. If you're still awake, breathe softly and let the next layer unfold. We continue now, seamlessly. Quantum energy is woven into everything, from the warmth of your skin to the glow of distant galaxies. But at its heart lies a simple, poetic truth. In the quantum world, emptiness is never truly empty. Even in a perfect vacuum, energy flickers in and out of existence. Physicists call this zero-point energy, the lowest possible energy state a system can have. Unlike a calm pond on a windless day, the quantum field cannot be perfectly still. It hums gently with an energy that never fades. Imagine standing in a silent forest before dawn. At first, it feels motionless, but as you pay closer attention, you hear faint tremors, distant insects, shifting leaves, the quiet inhale of the earth. Zero-point energy is like that subtle soundscape. It is not a force we feel directly, yet everything we know emerges from its presence. To understand why zero-point energy exists, think of particles not as tiny marbles, but as vibrations in fields that span all of space. Electrons are ripples in the electron field. Photons are ripples in the electromagnetic field. And like all vibrations, these fields cannot be perfectly motionless. They must oscillate, however slightly. It is a fundamental rule of the universe, one tied deeply to Heisenberg's uncertainty principle, which says we cannot know both a particle's exact position and momentum simultaneously. This uncertainty forces the fields to maintain a faint, unavoidable vibration.